It's a rainy day. Why not just watch from home? Look at these guys. Must be nice. All right. Yeah, I didn't get your test graded. Sorry. Might not be until next week. We'll see. I got a new computer that I'm pretty excited about. We're about to see how hopefully it will work out well the way I hope it's going to. All right. So today we are going to start talking about solving equations. All right. So an equation has to have an equal sign. All right, so it's considered a mathematical sentence. And a solution to the equation is a number that makes that equation true. When you solve an equation, it means you find all the solutions. All right, we use related operations or opposite operations to solve equations. So addition and subtraction are opposite operations, or we could say they're inverse operations. Okay, so for example, for the addition property of equality, if A equals B, then A plus C equals B plus C. So basically what that's showing right there is that you can add the same number to both sides of the equation and it'll still be true. Multiplication and division are opposite operations or inverse operations of each other. So if you have A equals B, then you can divide both sides by C as long as C is not 0, because you can't divide by 0. All right. Here's some steps to solving equations. You can, if you have fractions or decimals, you can multiply across the whole equation to clear away the fractions or decimals. You always want to simplify each side, so that could be distributing, combining like terms. And then you can do adding or subtracting the same number on both sides. You can do divide or multiply on both sides. And you can check your solution by plugging it back in. All right. So an identity is an equation that's always true. So For example, let's see. Well, why is it so fat? Okay, let's try that again. All right, so for example, 5 equals 5 would be an example of an identity. Okay, so in that case, if that's your equation, then that's just always true no matter what, right? And a contradiction would be something that's always false no matter what, so it has no solution. So for example, 5 equals 0 would be a contradiction. Okay. All right. So you guys that are on Zoom, is everything good? You can hear me, you can see the notes and everything that I'm writing? Okay, good. All right. Okay, so number 1, it says in the list of numbers, find the one that is a solution of the equation. So the equation is n minus 50 equals 8. All right, so let's plug in each of these numbers to see if it's a solution. So plug the number in place of n. So that would be 58 minus 50 equals 8. All right, so 58 minus 50 is 8. So 8 equals 8. So 58 is a solution. Okay, so if we was to plug in 42 for n, we'd say 42 minus 50 equals 8. Well, 42 minus 50 would be actually negative 8. So negative 8 equals 8 is false. So that shows that 42 is not a solution. If we use 60, it would not be a solution either. So 58 is a solution to that equation. 42 is not a solution to that equation. Okay. All right, so solve each equation and check the solution. So negative 5 equals n plus 3. All right. All right, so the variable, so the equation has 2 sides, right? So you have whatever's on the left of the equal sign is the left side of the equation, and whatever's on the right of the equal sign, that's the right side of the equation. So we want to get the variable, which in this case is n, by itself on one side of the equation. So we need to get rid of the plus 3. So we're going to do that by subtracting 3 from both sides of the equation. So the opposite of plus 3 is minus 3. So negative 5 minus 3 equals negative 8. So negative 8 equals n. And that's the solution to the equation. And then you could check that by plugging in negative 8 for n. So negative 5 equals negative 8 plus 3. So negative 8 plus 3 is negative 5. So negative 5 equals negative 5. So that is good. So you can always check the solution that way. I'm probably not going to check all of these because I don't want to. But you can do it that way if you're unsure. All right. Number 3, negative x equals 32. So negative x is the same thing as negative 1x. So like there's an invisible 1 there. So negative x is the same thing as negative 1x. So then let's divide both sides by negative 1, because negative 1x means negative 1 times x. So the opposite of multiplying by negative 1 is dividing by negative 1. So that gives me x equals negative 32. Number 4, we have 6z equals 12. So 6z means 6 times z. So the opposite of multiplying by 6 would be dividing by 6. So we're going to divide both sides by 6. So that is going to make it z equals 2. Okay, number 5, 0 equals negative 9t. Right? So negative 9t means negative 9 times t. So the opposite of multiplying by negative 9 is dividing by negative 9. So I'm going to divide both sides by negative 9. So 0 divided by any number is still 0. So and then the negative 9 cancels out. So 0 equals t. So that's our solution. This is nice because my left-handedness doesn't get in the way when I'm writing stuff. You know how when I'm writing stuff on the document camera, my hand's always, you know, kind of covering what I'm writing. And then like after class, I have like all the ink here, you know, so this is so much nicer. All right. Number 6, we have x minus 9x equals 80. So let's see. So x is the same thing as 1x. So we want to combine like terms. So 1x minus 9x. 1 minus 9 is negative 8. So negative 8x equals 80. All right. Then negative 8x means negative 8 times x. So the opposite of multiplying by negative 8 is dividing by negative 8. So then x equals negative 10. Okay, number 7. So again, we need to simplify each side first of all. So like negative 2 plus 11 would equal positive 9. So bring down the equal sign. And let's see, over here we have, there's an invisible 1 in front of that b there. So combine like terms, 2b minus 1b equals 1b, which is the same thing as just b. So I have b minus 9. So I have 9 equals b minus 9. And I want to get b by itself. So next I'm going to add 9 to both sides because the opposite of minus 9 would be plus 9. And then 9 plus 9 equals 18. So 18 equals b. All right. Number 8. So I need to simplify the right side of the equation. So negative 5 times 5 equals negative 25. So that's negative 25p. Okay, so I have 50 equals negative 25p. And then I can divide both sides by negative 25. So that gives me -2 equals P. Okay, number 9, I also need to simplify both sides first. So let's see, I've got -4n plus 3n, which would equal -1n, or in other words, -n, either way. I guess I'll just write -1n for right now. So I have 6 minus 1n equals, and then I can also combine these. 20 minus 35 would equal -15. All right, so I have 6 minus 1n equals -15. So next I'm going to subtract the 6 from both sides. So that gives me -1n equals -21. And next I can divide both sides by -1, which would give me n equals 21. Okay, number 10. All right, I have some simplifying I need to do here. All right, so -18 plus 3 equals -15. And bring down plus 13y equals, and then I'm going to distribute the 3. So that makes that 15y minus 3. And break down the -2. All right, let's see. Now I still need to simplify one more step over here on the right side. -3 minus 2 would equal -5. All right, and then I'm just going to bring everything else down. So I have -15 plus 13y equals 15y minus 5. All right, so now I've got y's on both sides of the equation, and I need to make it so that I only have y on one side of the equation. So I could either subtract the 15y from both sides, or I could subtract the 13y from both sides. Either way is just fine, whichever way you prefer to do it. I think I'm going to subtract the 15y from both sides. So then I have -15 minus 2y equals -5. I need more room. Yeah. Oh, well, figure something out here. Okay, so let's see, I need to get y by itself. So I'm going to need to add 15 to both sides. All right, so that will give me -2y equals 10. And then I will divide both sides by -2, which would give me y equals -5. All right. And number 11, I need to get p by itself, so I'm going to subtract 5 from both sides. So that would give me 7p equals 7, and then just divide both sides by 7. So p equals 1. Okay, I get it. Go away. Okay, okay. Okay. Leave me alone. Okie dokie. All right. Let's see. Okay. All right. We talked a little bit before about identities and contradictions already, although we haven't done any examples of those yet. Basically, all the examples that we've been doing would be known as conditional equations. Okay, so that's where there's basically just one solution to the equation, like x equals 2 or whatever. Okay, and so if x equals 2 is the solution, then they might write it this way and say the solution set is 2, like a set containing 2. So when you're doing your homework, it might just have like the little braces and you just type in the number 2. Okay, you don't necessarily type in x equals. All right. So basically what that means is the equation is only true if x is equal to that number. With an identity, the equation is always true. So x could be equal to any real number from negative infinity to positive infinity, and that equation is still true. And then for a contradiction, there's, no matter what, x can't be equal to any number to make the equation true. So it's no solution. So in other words, the solution set is the empty set, which is that symbol, like a circle with a line through it. That means the empty set. Okay. All right. So number 1, we need to simplify each side of the equation first. So 7x minus 5x equals 2x. And then bring down plus just everything else. Plus 15 equals x plus 8. All right. So x is the same thing as 1x. So we need to have x is only on one side of the equation. So I'm going to subtract 1x from both sides. So 2x minus 1x equals 1x, or in other words, just x. And I'll bring the rest down. So it's x plus 15 equals 8. And then I just need to subtract 15 from both sides. And that gives me x equals -7. All right, so that is another conditional equation. Number 2, so again, we need to simplify first. So let's distribute the 4. So that would be 4x plus 8. And then I'll distribute the negative 2, which will make that minus 2x minus 6. And then just bring down equals 5. Okay, and I still need to simplify by combining like terms. So 4x minus 2x equals 2x, and 8 minus 6 equals positive 2, and then I just bring down equals 5. So I've got 2x plus 2 equals 5. So next I'm just going to subtract 2 from both sides. So 2x equals 3. And then I will divide both sides by 2, which gives me x equals 3/2. Okay, so that's a simplified fraction, but if they wanted a mixed number, you could change that to a mixed number. 2 goes into 3 one time with 1 left over, so that's the same thing as 1.5. Okay. Any questions? All right. Let's see here. I hope I have enough room to do these. They look kind of long. Okay. Let's see. We need to simplify the left side of the equation. We need to distribute that negative. So that's going to be negative 4x minus 8. And then I'm going to bring down the 6x and the brackets and the negative in front of the brackets. And all that is equal to, okay, those parentheses are not needed at all. So I'm just going to write 9 plus 6x plus 3. All right. Looking back at the left side of the equation, inside the brackets, I still need to combine the like terms. 6x minus 4x would equal 2x. And then I'm just going to bring down the minus 8 as well as the brackets with a negative in front of them equals. On the right side of the equation, I'm going to go ahead and combine the like terms. 9 plus 3 is 12. So I've got 12 plus 6x. And then I'm going to finally go ahead and distribute the negative through the brackets. So I've got negative 2x plus 8 equals 12 plus 6x. All right, so now both sides are fully simplified, and I just need to get the x's to one side. So I will do that by subtracting 6x from both sides. And that gives me negative 8x plus 8 equals 12. Then I would subtract 8 from both sides, which gives me negative 8x equals 4. And then I'm going to divide both sides by negative 8, which would give me x equals negative 1/2. Okay. Number 4. All right, let's see. So I'm going to distribute the -5 here. So that's minus 5m plus 5. And I'm going to bring down -3m plus 6. So I've got -3m plus 6 minus 5m plus 5 equals, let's see, I'll bring down minus 5m here. And then I'm going to go ahead and distribute that negative. So that's going to make that minus 2m plus 4. And then bring down the plus 5. Okay, going back to the left here, combine the like terms. -3m minus 5m would equal -8m. And 6 plus 5 would be plus 11 equals, and then -5m minus 2m would equal -7m. And 4 plus 5 is 9, so that's plus 9. All right, so I have -8m plus 11 equals -7m plus 9. So now both sides of the equation are simplified, and I just need to get all of the m's on one side of the equation. So I'll do that by, I'm going to go ahead and add 8m to both sides this time. Sorry. So that would make it 11 equals, and then -7m plus 8m, that's just going to be positive 1m. So just m plus 9. Okay, and then finally, I just need to subtract 9 from both sides. So 11 minus 9 is 2. So 2 equals m. All right. Number 5. So number 5 has a bunch of fractions on it. So whenever I have an equation that has a bunch of fractions on it, what I would like to do is start by clearing that fraction out. And I can do that by, first we got to find the LCD for all of those fractions. So what do you think the LCD is? So we're looking at 4 and 3 and 6. So what could all of those go into? So one way to figure that, yeah, 12. Yeah, at first I was thinking 24, but then I realized, wait, actually we could do 12 would be smaller. That would work. Yeah, one way to think about the LCD is, I know I showed you all how to do it with factor trees before, but you can also do it by looking at the biggest one, which in this case would be 6, and then just thinking of all the multiples of 6 and see if they, so like, okay, can 4 go into 6? Well, no, so 6 can't be the LCD, but what's the next multiple of 6? Well, 2 times 6 is 12. And then, well, can 4 go into 12? Yeah. And can 3 go into 12? Yeah. So that makes 12 our LCD. So our LCD is 12. All right. And then, so then we have to multiply each term of the equation times 12. So you could think of that as 12 over 1 if you like. Basically, you're going to multiply, you know, if it's a fraction, you're multiplying the numerator by 12. And then each term still has to get multiplied by 12, even if it's not a fraction. So that 5 on the end has to get multiplied by 12 also. And then before we actually multiply 12 times 3, instead of doing that, let's just see if we could reduce that first. That's kind of the whole point. So 4 goes into 12 3 times. And then 3 times 3 would be 9. So this would just be 9x minus, and then 3 goes into 12 4 times, and 1 times 4 is 4, so that would just be 4x equals, and then 6 goes into 12 2 times, and 5 times 2 is 10, so that would just be 10x minus, and then 5 times 12 is 60. So I just have 9x minus 4x equals 10x minus 60. All right, so now I'm rid of all those fractions, and I just want to combine the like terms. 9x minus 4x equals 5x, and just bring the rest of it down. So I got 5x equals 10x minus 60. Okay, but I still have x's on both sides of my equation, and I need to get it to where I only have x on one side. So I'm going to do that by subtracting 10x from both sides. So that would give me negative 5x equals negative 60. And then divide both sides by negative 5, which gives me x equals positive 12. All right, so far, again, all we've seen are conditional equations that just have a normal answer to them. Okay, so number 6, again, we've got fractions all over the place here. So I'm gonna, again, say let's start by figuring out the LCD. So what would be the LCD? We're basically, well, we can actually go smaller than 12. Yeah. So 6 is the LCD. All right. So we're going to multiply each term. So since we have like sort of like 2 terms in each numerator here, we want to put parentheses around that, you know, the 4t plus 1. We want to put parentheses around each one of these so we make sure we know we have to like distribute. All right, so we're going to multiply that by 6, and that by 6, and that by 6. So, and again, let's reduce. So 3 goes into 6 2 times. So really we just have to do 2 times 4 plus 1. Or I'm sorry, 4t plus 1. Equals. And then here 6 cancels out. And on the last one, 6 cancels out as well. So in that case, I'm just going to, I don't really need the parentheses now. I'm just going to bring down t plus 5 plus t minus 3. And now we just need to simplify. So I'll go ahead and distribute the 2, which is going to give me 8t plus 2. All right, equals, and then combine like terms. So t plus t equals 2t, because that's like 1t plus 1t equals 2t. And then 5 minus 3 is positive 2. All right. Okay, so now everything's simplified, but I have t on both sides, so I just want to get it where I have only t on one side. So I'm going to subtract 2t from both sides. So that's going to make it 6t plus 2 equals 2. All right, and then subtract 2 from both sides. So that gives me 6t equals 0. And then I'll just divide both sides by 6, which gives me t equals 0. Yeah, of course. I'm just going to keep teaching to an empty room because I have 3 people on Zoom, so they count. All right. All right. Any of y'all have any questions on Zoom? And y'all know y'all can print these notes out. They are on Canvas. So if you are planning to, when you are planning to watch from home, you can always go on the Canvas modules and print these out. So it kind of helps you go along with me, even from home, just like you do in class. All right. Okay. So next we have a bunch of equations that have a bunch of decimals in them. So what we can do to make that a little easier, just like we did with the fractions, we multiplied by the LCD, basically do the same thing here, except for instead of figuring out the LCD, we just are going to multiply by a power of 10. So a power of 10 means either 10 or 100 or 1,000 or 10,000 or something like that, just depending on which, how big the decimals are basically. So like on number 7, if I look at the decimals, I can see that they each have 2 digits after the decimal point. So that means that they're going to the hundredths place, because the first one is tenths and the second one is the hundredths place, right? So that means what I want to do is multiply this whole entire equation times 100 to clear the decimal out. So when you multiply by 100, you're basically, it's just the same thing as moving the decimal point 2 times to the right. So 100 times 0.09 would just be 9. So that would be 9K. And then plus, so then 100 times 0.13, that would just be 13. Okay, and this whole thing right here is one term. So when we've already multiplied 100 times the 0.13, we don't need to multiply it with what's in the parentheses yet. So the part that's in the parentheses right there, K plus 300, that's just going to stay the same. Equals, and then 61 times 100, so that's just going to be 6,100. All right, so now we got rid of the decimal. So now let's just simplify by multiplying by 13, or distributing that 13, so it's 13K plus, and then this would be 3,900. And I'm going to bring the rest of it down. So I have 9K plus 13K plus 3,900 equals 6,100. All right, and then I'm going to combine the like terms. So 9K plus 13K equals 21K. And I'm going to bring the rest down. So 21K plus 3,900 equals 6,100. And then I'm just going to subtract 3,900 from both sides. So that makes 21K equals And so let's see, that's going to be 2,200. Okay, seems kind of weird, but I think that is what it is. So now I just divide both sides by 21. So I think 7. Oh, but let's see. So, So they probably would want the answer to be in the form of a decimal. So I guess we'll just divide, like with long division. Okay, so 21 goes into 2,200. So 21 goes in 22 one time, and then 1 times 21 is 21. 22 minus 21 is 1. Bring down the 0. So 21 can't go into 10, so that would be a 0. And then bring down another 0. And then 21 would go to 100 4 times. And 4 times 21 is 84. 100 minus 84 is 16. I'm just checking again because it seems so weird. But I don't see anything wrong with it. Oh, wait. Yes, I do. Duh. 9 plus 13 is 22, not 21. That's why it's so weird. Okay. All right. That's this. Okay, that's never mind all that long division. Okay. Okay. There we go. That makes much more sense now. So divide both sides by 22. And then you just get K equals 100. There we go. That's nice. All right. So number 8. Okay. So in this case, the decimals, we have tenths, hundredths, thousandths. So it's going out to the 1,000th place. So that means we need to multiply the whole equation times 1,000. All right. Okay, so if you multiply by 1,000, you're just moving the decimal point 3 times to the right. So 1,000 times 0.004 is just going to be 4. So that's going to be 4x plus 6. And then again, this part in the parentheses won't change. So 6 times 50 minus x equals, and then that'll be 4 times 68. So that takes care of the decimals. And then we will distribute the 6. All right, so 6 times 5 is 30, which means 6 times 50 is 300. minus 6x. So I'll break down 4x plus, so I've got 4x plus 300 minus 6x equals, and I suppose I should go ahead and multiply 4 times 68. Okay. 4 times 8 is 32. Break down the 24, that's 27. So 272. All right, and combine the like terms on the left. 4x minus 6x equals negative 2x. So negative 2x plus 300 equals 272. And then next, I'll go ahead and just subtract 300 from both sides. So negative 2x equals negative 28. And then just divide both sides by negative 2, which gives me x equals 14. All right. Okay, solve each equation and decide whether it's conditional, identity, or contradiction. Okay, so finally, maybe we'll have some examples of everything we did so far has been conditional, so maybe we'll finally have some where we have identities and contradictions. Okay. So negative 12x plus 2x is negative 10x. Bring down minus 11 equals. Distribute the negative 2. So negative 10x plus 6 plus 4. And we just need to combine on the end here. 6 plus 4 would be positive 10. And I'm just going to bring everything else down. So I have negative 10x minus 11 equals negative 10x plus 10. So I see that I have x's on both sides of the equation. So I would fix that by adding 10x to both sides of the equation. And in this case, that's actually going to cancel out on both sides. So then that would mean that negative 11 is equal to positive 10. And that is false. There's no solution. Okay. No solution, or we might say that the solution set is the empty set. And so because of that, then also we would call that a contradiction. Alrighty. Number 10. So start by distributing that 4. So that's 4d plus 28 equals, and then let's combine the like terms. So 2d plus 2d equals 4d, and then 25 plus 3 equals positive 28. And then I see that I have d on both sides of the equation. So to fix that, I would subtract 4d from both sides. And it's going to actually cancel out on both sides, which leaves me with 28 equals 28. So that is true for any value of x. So that is known as an identity. And the solution, there's an infinite number of solutions, all real numbers, which can also be written like this, as negative infinity to infinity. So any real, no matter what value you plug in for that variable, the equation is still true. So the solution set is the entire set of real numbers. Number 11, let's see, just want to simplify a bit by doing 4 minus 9 equals -5. And then I'm just going to bring the rest of it down. So I have 2x minus 5 equals 4x minus 5. And I see that I have x's on both sides. So I will subtract 4x from both sides. So negative 2x minus 5 equals -5. And next I would add 5 to both sides. And that gives me negative 2x equals 0. And then I'll just divide both sides by -2, which gives me x equals 0. And so that means that that is a conditional equation. As opposed to an identity or a contradiction, it's conditional. So it's only, so that equation is true only under one condition, that x is equal to 0. All right. We made it through. So I'll see y'all tomorrow. Let me know if you have any questions.